In this video, let us look at what a composite function is. So let us take a function f defined from a set x to a set y1. So let f be a function defined from x to y1, and g is a function defined from some y2 to a set y. So my function f is defined from x to y1, my function g is defined from y2 to y. For example, so let us take a function f defined from x to y1. So let x be 1, 2, 3, 4, and let y be a, b, c, d, e. And let the function be 1 is related to a, 2 is related to c, 3 is also related to c, 4 is related to d. Next, let us take a function g. Let us take a function g defined from y2 to y. So let y2 be the set containing b, c, d, e. 4 elements, and here you have 10, 11 and 12. So let G relate B to 11, C to 12, D to 10 and E back to 11. So you have F from X to Y1 and G from some ZY2 to Y. Now let D be the set of elements of the set X. So let D be the set of elements of the set X such that f of x belongs to the set Y2. So let D be the set of elements of X such that the image of that element belongs to Y2. That is, as you can see, f of 1 is equal to A, f of 2 is equal to C, f of 3 is equal to C, f of 4 is equal to D. So there are 4 elements in X. So what is the set of those elements in X such that their images belong to Y2? So as you can see, f of 1 is A does not belong to Y2. So I'm not considering A. I'm not considering 1. So f of 2 is C and C belongs to Y2. f of 3 is C again and C belongs to Y2. f of 4 is D and D belongs to Y2. So now I consider the set D as the set containing 2, 3 and 4. Now I define a function H. I define a function H of X on the domain D such that H of X is equal to, the definition of H of X is G of f of X. So G of f of X, and this is called a composite function of G and F, and this function H of X is denoted by GOF. This H of X, which is G of f of X, is called the GOF function, GOF function. So let us try to analyze what H of X does. So what H of X does is, H of X is defined on the set 2, 3, 4. That is, the domain of H of X is 2, 3, 4. And now what is the image of an element by the function H? H of 2. So if you want H of 2, this is nothing but G of f of 2. That is equal to What is f of 2? F of 2 is c. That is g of c. G of c is 12. Is equal to 12. That is 2 is related to 12. Now, what is 3 related to? So, h of 3 is g of f of 3. F of 3 is c and g of c is 12. That is 3 is also related to 12. And what is h of 4? H of 4 is equal to, by the definition, g of f of 4, that is equal to g of f of 4 is d, is g of d is equal to 10. So that means 4 is related to 10. So as you can observe, this is what g of f of x does. This is a composition of g and f. So as you can see, the domain of g of f, the domain of GOF, is a subset of the domain of f. The domain of GOF function is a subset of the domain of f. And the range of GOF is a subset of the range of G. The range of GOF is a subset of Y, that is the range of G. So these are the two things that you need to remember. The domain of GOF is a subset of the domain of F, and the range of GOF is a subset of the range of the second function G. Now let us go further and analyze some more important points about the composite functions. So now we have seen that if f is a function defined from x to y1 and g is a function defined from y2 to y, the domain of the composite function GOF, the domain of this function is a subset of the domain of the first, that is f function, and the range of GOF is a subset of the range of G. And the naming GOF starts from back to first, that is, if you have a function f like this and if you have a function g like this. So suppose that GOF, if it has to be defined on the domain of f, so if the domain D of G of f is equal to the domain of fx, so this has to imply that the range of f, if all the elements in the range of f are present in the domain of G, that is the range of f, if it is a subset of domain of G, then GOF function can be said to be defined on the domain of f. That is, if you have 1, 2, 3, 4 here, you have A, B, C, D, E, and 10, 11, 12. So 1 goes to B, 2 goes to C, 3 goes to C, 4 goes to E. And B goes to 10, C goes to 12, A goes to 11, B goes to 11, E goes to 12. So if this is the function f and if this is the function g, what is the range of f? So the range of f is nothing but the set of second elements in the function f, that is the set containing B, C and E. So if the range of f is a subset of the domain of G, that means every element will be connected to another element through the element G. Then the domain of GOF, so GOF can be said to be defined from X to the set Z. So GOF 1, 2, 3, 4. So 1 is going to B, B is going to 10. So 1 goes to 10. 2 goes to C, C goes to 12. So effectively 2 goes to 12. 3 goes to C, C goes to 12. So effectively 3 also goes to 12. And 4 to E, E to 12. So 4 also is going to 12. So X GOF is defined on the domain X. And you can think of Z as the codomain. And you can see that the range of GOF is always a subset of the codomain of the second function Z. Or you can also say the range of the function G. The domain is a subset of the domain of F. The range is a subset of the range of G. And if the function has to be defined on the set X, then the range of F has to be a subset of the domain of G. So this is a very standard condition. If GOF exists, then the range of F has to be a subset of the domain of G. Then GOF exists on the domain of F. So this is a very important condition. If you're asked to check whether GOF exists or not, you just need to check this condition. The range of F has to be a subset of the domain of G. Then GOF exists on the complete set X. Now, what are the properties of the composite function?